Hi, we are the PSEG Institute for Sustainability Studies Green Team serving Jersey City. I am Saul Contreras, a physics major from Montclair State University.
I'm Jitsia Guzman, a Geography, Informational Systems, and Sustainability major at Rowan University.
I'm Miranda Muniz, and I'm Sustainability Science major from Montclair State University.
I'm Javonica Lattimore, an Environmental Engineering major at King University.
And my name is David Lisboa. I'm a biology major from Fairleigh Dickinson University.
So this is just some background information on Jersey City. Jersey City is located in Hudson County, New Jersey. It has a population of 265,549 citizens since the 2018 Census Bureau. There are 6 wards outlining Jersey City. In the summer of 2019, Jersey City did a collaboration with New NJCU on tree mapping within Wards A. Jersey City this summer of 2020 was asked us to make progress in accurately mapping and analyzing the city's trees, which was continuing the work done in 2019 of mapping Ward A into Wards B and Ward F. We were asked to estimate carbon sequestration, which is the carbon intake of each tree within Jersey City using an infrared gas analyzer, and make recommendations on communicating tree-related information to the public, as well as develop a report and presentation that offers a plan on improving the city's trees.
There are many benefits of having street trees in urban areas. Street trees in urban areas provide shade, which can cool the temperature of the area. They also increase the air quality and produce oxygen while absorbing rainwater, which can lead to lower levels of flooding, which is really important during times of intense storms. There's a lot of also benefits to tree mapping that goes beyond just having the GPS points of the trees in the city. It gives a forester an index of all the tree species in Jersey City, and in that we can see which tree species are capturing the most carbon. It also gives the forester the conditions of the trees in Jersey City and gives them a map of where the dead and unhealthy trees are in the city that can be removed. And it also gives them a map of where all of the empty pits are in the city, where there were trees, but now there is an empty location. So when the forester is looking to increase the tree canopy quickly, they have a map of all of the empty spaces in the city where trees can be added.
These were some of the tools we used to collect our data. We used an ERGA portable photosynthesis that was able to measure our carbon sequestration from each tree. We used a Leica Xeno 20 that allowed us to take down the points on the GPS to say this is where this tree is. We used Survey 123 mobile app to collect the information of each tree, specifically the species, the diameter at breast height, and the pit length and width. We also used ArcGIS Pro to create an interactive map for the forester of Jersey City, as well as the public.
Ensuring accuracy was a really important component of our project. Since we were working with GPS points, we were getting that information from satellites, but satellites don't stay still throughout the day, they move, and that changes the accuracy of the points. So we found that at certain times of the day, we were actually able to gather more correct data, more accurate data, depending on where the satellites were at that point in time. So one reason that it's really important to have that precise GPS data is if we're collecting all of these attributes of the trees to give to the forester and give to the city, but they can't find the tree that we're talking about, then it pretty much makes our information useless. So it was really important to us. We also tried to be accurate when labeling the condition of the tree, if it was dead or unhealthy, so the forester would know which trees to focus on first. And then accuracy really just saved time by giving the city and the public information that they can trust. And one of the tools that we used in our data collection to ensure this was the Leica Xeno 20. The Leica Xeno 20 we found has an average of really high accuracy by also giving us X and Y coordinates instead of something a bit more vague like a street address. And it gave us a figure ID for easy identification. And we used this in collaboration with a MiFi, which is portable Wi-Fi, to also help us with our field work.
And this map shows the progress we have made this summer in mapping Ward B and F. Each point is color-coded to indicate the condition of the tree. The black squares are pits, red are dead trees, yellow are trees we found to be visibly unhealthy, such as having branches with no leaves or having damaged bark, and green are the healthy trees. We also looked at different characteristics such as the diameter at breast height, the pit length and width, the scientific name, and we included a photo showing physical damage of the tree. And this is a pie chart showing the tree conditions in wards B and F. Although it was shown that the majority of trees were unhealthy, we saw that about 20% of trees were just empty pits where new trees can be added. 2% were dead trees, so these need to be removed and hopefully replaced. And then 22% of trees were unhealthy, so these just need to be kept a closer eye on so that they don't end up being dead trees.
If you look at the graph on the top left, we compared the health of the tree among the species, and we did this by conducting an analysis on variance followed by a Tukey post hoc mean separation. And from this, we can see that on the left, the London plane and all of the trees up to the Bradford pear are relatively healthy in our data sample. And the last 4 trees on the right there, the Bradford pear, the white ash, the honey locust, and the Japanese pagoda were relatively unhealthy within our data set. Now, if you see on the graph on the bottom right, you can see that there were more healthy trees in Ward B and more unhealthy trees in Ward F. And that was because we think Ward F is a more industrial area, while Ward B is more residential and may have better conditions for tree growth.
So another thing that we collected when collecting data for the trees was the DBH, or the diameter at breast height. We found that actually a lot more trees were younger trees. That's why you see that big bar for the 15 to 30 centimeter size. These DBH is actually really helpful in collecting and adding to the carbon sequestration data. It helps us get the surface area of the leaf, and it also helps us find and figure out how much carbon the tree is sequestering.
We wanted to see if there was a relationship between the condition of the tree and the pit area. We initially hypothesized that the smaller the pit area, the worse the tree condition would be. But statistics showed that there was no clear correlation between the pit area and the tree condition. We in fact found that the healthy trees were able to be found in pits of various sizes. We also found that there were many unhealthy trees within the smaller pits. Here we have a plot with a plentiful bunch of information. On the left-hand y-axis, we have the tree count. On the x-axis, we have the species. And on the right-hand y-axis, we have the net carbon flux. The thicker bars represent the tree count. So as you can see, the London plane is the tree that we encountered the most. A close second was the Bradford pear, which we also encountered quite a bit. And the thinner bars represent the net carbon flux. The tree that we encountered that had the highest net carbon flux was the green ash. A close second was the little leaf linden. The yellow bars are the trees that we would recommend based off of their average healths. And the brown bars we wouldn't recommend. We were able to estimate that there are 23,346 trees in Jersey City, and the amount of carbon that they sequester million be conceptualized in terms of 3.5 million pounds of coal burned, about 7.9 million miles driven by an average passenger vehicle, or about 404 million smartphones charged. So just think about that amount of energy that is sequestered by the trees. It just shows how valuable the city's green infrastructure is with respect to helping take up carbon, because we know that there's 417 parts per million of carbon dioxide in the air, and we have to act on that. We also see that if all of the pits were filled if all of the pits on healthy trees and dead trees were replaced by healthy trees, we would see a 57% increase in sequestration, which just shows that there is plenty of potential for increase in sequestration.
One of our deliverables, as stated before, was reaching the public and making Jersey City's website more attainable and more user-friendly. So in those efforts, we created some infographics that'll help the public get a better understanding of exactly what a tree canopy is and how helpful the trees in front of their houses actually are. So on the left, you see the healing and beautifying your trees pit infographic, and we just have 1 and 2 as just like healthy, like maintenance kind of ways that they can just maintain their pit by like watering and adding a mulch. Number 3 is also maintenance, as in like picking weeds, just keeping the pit as clean as possible. Number 4 is for more like a look, like to make have a prettier curb appeal. So we had put add annual flowers, which is really good and is okay for the pit and it's safe. Number 5 is just like a big don't that we really wanted to emphasize, which was avoid filling the empty pits. And number 6 is actually to do some more research if they don't understand. They can scan that QR code using their cell phone, and it'll actually take them to the doc on the right, the how to care for your pit and the adding to your pit. So how to care for your pit just talks about the proper mulching techniques. The information was taken from the New Jersey Tree Foundation. And it's just little quotes from there. And it also gives them some mulch options that are really good. We found that organic mulch actually does better than inorganic mulch. And then adding to your pit just talks about the possible flowers that they can add to their pit that are all annuals, and the certain seasons that they can plant them in. And then at the bottom, there's also another link to take them to garden.org, which is a whole catalog of more annuals that they can possibly plant. The last one is the one in the middle. The Arbor Day celebration is just something that we've talked about, possibly having the city get a little bit closer with the residents by just creating a little like party kind of celebration thing on Arbor Day where they talk about trees and there's sustainable vendors, there's music, there's food, families can come, it's free of entry, just to get people a little bit more involved in understanding tree canopy and the help in tree health.
And in making our data more available and transparent to the public, we created this Jersey City Tree Canopy dashboard, which will be incorporated into the Jersey City website. So all the charts and graphs are completely interactive. And we also included this video, which explains what a tree canopy is, as well as why it's beneficial to the city. And when you select a point on the map, you get a pop-up, which tells you all the attributes we mentioned earlier, as well as a photo of the tree.
We'd like to just give a huge thank you for the people that allowed us to do this project and the people that also helped us along within this project. Starting with Ms. Kate Lawrence, Carolina Ramos, Edward O'Malley, Dr. William Montgomery, Lindsay Sigmund, the City of Jersey City's Division of Architecture, Dr. Dirk Vanderkline, Dr. Josh Galster, Yvette Villasus, Amelia Miller, and Dr. Amy Tuninga.
We would also like to thank our funders for making this project possible.